For centuries, humans believed that the planets we see in our solar system were the only ones out there. But in the last few decades, that idea has been completely shattered. Astronomers have discovered thousands of planets orbiting stars far beyond our sun. These distant worlds are called exoplanets, and they've completely changed the way we think about the universe. Some of them are massive gas giants, larger than Jupiter. Others are rocky, small, and surprisingly familiar. And the biggest question is this: could any of them be like Earth? Could there be another world out there with oceans, clouds, and maybe even life? This mystery has fueled some of the most exciting discoveries in modern astronomy. From powerful space telescopes to groundbreaking detection methods, scientists are scanning the skies like never before. And every new exoplanet we find brings us one step closer to answering one of humanity's biggest questions. Are we alone? Or is there another Earth waiting out there in the stars? So, what exactly is an exoplanet? The word itself is short for extrasolar planet, which simply means a planet that orbits a star outside our solar system. In other words, any planet that doesn't orbit the sun is considered an exoplanet. For most of human history, we had no way of knowing if planets existed around other stars. They were too far away and too faint to see with traditional telescopes. That all changed in the 1990s, when astronomers detected the very first confirmed exoplanet orbiting a star like our sun. Since then, the discoveries have exploded. Today, thanks to advanced telescopes and space missions like NASA's Kepler and TESS, we've identified more than 5,000 confirmed exoplanets, with thousands more candidates waiting to be studied. But how do we actually find them if we can't see them directly? Scientists use clever methods. One is called the transit method, where a planet passes in front of its star and causes a tiny dip in brightness. Another is the radial velocity method, which measures the slight wobble of a star as it's tugged by a planet's gravity. These techniques let us detect worlds light years away without ever taking a picture of them. Each new discovery has expanded our view of what's possible. From super-hot planets orbiting their stars in just a few days, to giant gas worlds bigger than anything in our solar system, the diversity is mind-blowing. And the more we look, the clearer it becomes. Planets are everywhere. The next step is to ask, what kinds of exoplanets are out there, and how do they compare to the worlds we already know? When we talk about exoplanets, not all of them are anything like Earth. In fact, most are wildly different. Astronomers have categorized them into several fascinating types. First, there are hot Jupiters. These are massive gas giants, similar in size to Jupiter, but orbiting extremely close to their stars. Because of that, their temperatures can reach thousands of degrees, making them blistering worlds of fire and gas. Then we have super-Earths. These are rocky planets larger than Earth but smaller than Neptune. Some might be covered in oceans, others could have thick atmospheres, and a few are even located in the so-called habitable zone where liquid water might exist. Super-Earths are among the most exciting discoveries because they may hold conditions suitable for life. Next, are mini Neptunes. These planets are smaller than Neptune, but larger than Earth, with thick, gaseous atmospheres. They might not be habitable, but they teach us about the variety of planetary systems in the universe. There are also rogue planets, drifting alone in the dark, not orbiting any star at all. Imagine a lonely world wandering through interstellar space with no sun to warm it. What's truly amazing is that exoplanets challenge our imagination. Before their discovery, we thought planets would mostly resemble the ones in our solar system. Instead, we've found scorching lava worlds, water worlds, frozen giants, and even planets orbiting two suns. Just like in a sci-fi movie, each type adds another piece to the puzzle, helping us understand how planets form and evolve. And it brings us to the ultimate question: could any of them be like Earth? If we want to find another Earth, the key lies in what astronomers call the habitable zone. This is the region around a star where conditions might allow liquid water to exist on a planet's surface. Too close, and the planet becomes scorching hot, like Venus. Too far, and it turns into a frozen desert, like Mars. Within this narrow band, some exoplanets have already sparked global attention. One of the most famous is Kepler 452b, often called Earth's cousin. It's about 60% larger than Earth and orbits a star similar to our Sun. Scientists believe it could have rocky terrain and possibly water. Then there's Proxima Centauri b, the closest exoplanet to us, orbiting the star nearest to our solar system. Being in the habitable zone makes it an exciting target, though we still don't know whether its surface is friendly to life or battered by radiation from its star. We also have the TRAPPIST-1 system, with 7 Earth-sized planets orbiting a single star. At least 3 of them sit in the habitable zone, raising the possibility of multiple Earth-like worlds in just one system. The idea of a planet with blue oceans, green landscapes, and breathable air somewhere out there is more than just science fiction. The search for these worlds brings us closer to answering the timeless question: are we alone in the universe, or is another Earth waiting to be found? Finding exoplanets is not as simple as pointing a telescope at the night sky. These planets are incredibly far away, often hundreds or even thousands of light years from Earth. They are also faint compared to the stars they orbit, making them nearly invisible to the naked eye. To overcome this, astronomers use clever techniques. One of the most successful is the transit method, where scientists watch for tiny dips in a star's brightness. When a planet passes in front of its star, even just a fraction of a percent of dimming can reveal its presence. Another method is the radial velocity technique, which detects the subtle wobble of a star caused by the gravitational pull of an orbiting planet. This wobble is too small to see, but with sensitive instruments, scientists can measure it. Space telescopes like Kepler, TESS, and the powerful James Webb Space Telescope have opened our eyes to a universe filled with planets. They allow us not only to detect these distant worlds, but also to study their atmospheres, searching for signs of water, oxygen, or even potential biosignatures. But challenges remain. Many exoplanets are so far away that we may never send spacecraft to visit them. The signals we detect are faint, and it takes years of observation to confirm a single planet. Still, with every discovery, we sharpen our tools, improve our techniques, and get one step closer to finding a true twin of Earth. The search for exoplanets is more than just science. It's a reflection of our deepest curiosity as humans, the desire to know if we are alone in the universe. Every new discovery pushes the boundaries of what we thought was possible, reminding us that our solar system is just one small neighborhood in a vast cosmic city. Somewhere out there could be a world with skies as blue as ours, mountains taller than Everest, or oceans deeper than anything we've ever imagined. Maybe life has already taken root on one of these planets, evolving in ways we can't even picture. Or maybe, just like us, someone is staring at the stars, wondering if they're alone. While we may be decades or even centuries away from visiting these worlds, the search itself changes us. It forces us to look up, to dream bigger, and to understand our own planet more deeply. So, what do you think? Could there really be another Earth waiting out there in the cosmos? If you're as fascinated by this mystery as I am, make sure to subscribe, drop a comment with your thoughts, and join me as we keep exploring the unknown. The journey to the stars has only just begun.